Hello. Hello.
Hey, how's it going?
Pretty all right. Good. You can see that I'm in the conference room.
Oh, you did end up coming.
Yeah, because I thought we were meeting here, but okay.
Oh, wait. Oh, did you not get our texts?
No, I literally just saw them.
Oh, I'm sorry.
No, it's fine because I prefer to be here because I know it's gonna be quiet.
Okay, that's good then. Okay. So Asta's not on yet. All right, so maybe we should wait a couple minutes before we start.
Yeah.
Okay.
So when you said that I should go over um the syntax and definitions, is that all the way up until common mistakes?
Asta, do you still want to go over common mistakes or do you want Steven to do that? I,
Um,
I mean, I guess sort of we figured out that when we started talking about syntax, we sort of went into the common mistakes.
yeah.
So, yeah.
Yeah, we can leap the we can bring those together.
Okay.
Okay.
Um,
Hello.
Yes.
Oh, I thought my internet froze for a second.
No, you're still there.
I think Austin's internet might have cut out again.
Uh-oh.
Oh, I thought it was something else.
Yeah. Didn't she say she got a Ethernet cable?
Yeah, she said that she would be getting one, but I don't know if it already came. Hey, Shiraz.
Hey man.
So we're just waiting a couple minutes for Asleep to come.
Yeah, she says she has some technical difficulties with the Wi-Fi.
Yeah.
Yeah.
It always happens when we have webinars, but when it's the one-on-one tutoring sessions, it'd be pretty good.
Yeah.
Yesterday helped out a lot.
Oh,
Good.
I didn't get a chance to look at the debugging for the clips, but I'm gonna look it up today, and that's gonna help out a lot just for the thought process for the memory simulation. How to write it down by hand. Just tracing just be a great thing to do, just to master it.
yeah, definitely.
Yep. So I just gotta keep working at it, and then it's gonna be a time where it's just gonna be second nature to me.
Yeah, I mean, definitely practice makes perfect. I mean, like, I remember my first time tracing out code was not so good.
Yeah, at the University of Maryland.
I wonder how many people are going to come today.
Yeah.
What, for the webinar?
Yeah.
Because did you say there were a lot of people that came last Saturday?
Yeah, I mean, there were like probably like 5, 6, maybe like at most 7 people that came. Hannah, do you just want to like, if she's not here in like the next few minutes, you just want to like start it, and then when she so I don't see any like purpose in like delaying it anymore.
Yeah. That's fine. Do you want to wait like 2 more minutes to see if anybody else gets on, and then we can start?
Yeah.
Okay.
Hey, in college, are you guys like juniors or seniors? Like about to graduate?
Oh no. I'm actually a sophomore.
Oh, you're
I'm
actually a
freshman.
sophomore? Wait, you say you're a freshman?
Yeah.
Wow. I thought you guys were seniors and juniors. You guys know so much. It's pretty amazing.
Thanks, I guess.
Yeah.
Are you a senior?
No, I'm a junior. I'll be a senior next year.
Nice.
Yeah. Just internship and stuff next year.
That's good. So do you want to go into computer science?
Yeah. It's like I'm interested in biology and computer science. I don't know where to go with it.
In
So I might just-
biology and computer science?
Yeah.
Hmm.
Yep.
Wow, yeah. I mean,
Might just be a bioengineer.
yeah, that's a good idea. And I feel like computer science kind of just like whatever field you go into, just because everything is with computers now. So just knowing computer science and whatever you go into is really helpful.
Yeah, computers are everywhere.
All right, do you think we should start, Steven?
Yeah. All right. So, hi guys. Thanks for coming to today's webinar. If you guys have been paying attention to the group chat, then you'll know that this webinar is pretty much just a duplicate of Wednesday's webinar, and it'll be on arrays. So, I guess we should just get started right away. I'm going to be going over like the basic definitions and syntax for arrays, and then I'm going to hand it off to Hannah, who's going to talk more about either common mistakes or other stuff. So, I guess, Hannah, did you show the picture of the lockers for the definition?
Yeah, I think Asta showed them that, yeah.
Okay. So if I share my screen, can you guys see my screen?
Yep, I see it.
Okay, so if we look at the ebook has a pretty nice graphic that shows the basic structure of an array. And an array is basically, well, if I read the formal definition, it's a consecutive storage for multiple items of the same type. But really what it is just, it's an ordered collection of, well, items that are of the same type. So if you had like a bunch of integers that you wanted to keep track of, but you didn't want to make like, let's say you had like 5 integers that you wanted to keep track of, but like you didn't want to make 5 separate different integer variables, then you could store them into an array. And kind of like looking at it as an abstraction, it's kind of like a row of lockers or like cubby holes, because they're ordered and you know what you can store in them. Like in a locker, you can store like your books or like your bag, but they're really just like the same type of item that like you're storing into them. It's kind of the same idea with an array. So like you can have an array of integers where you only store integers, or you can have like an array of doubles where you only store doubles, or an array of chars where you only, well, really that's just a string, but I'm not going to get into that. Have like an array of pretty much any type of object that you want. And so does that make sense? Like just looking at it basically?
Yeah.
Okay. Next, we're going to go over the basic syntax of like how you declare an array. So, one thing that I also want to mention is that arrays are objects, just like, in Java you have objects, like a string is an object, a scanner is an object. Like you can make like any class itself is an object, or when you use like new class name, that is an object. So just keep that in mind, because they're not like, you can't say like int brackets high scores equals 4 and then make it like an array of size 1 that has like an element 4. It's not going to work. So you have to keep in mind that they are objects, and that if you look at it in memory, you would like when you say like new, then like you're actually making an array in memory on the heap. So if we look at this example to declare arrays, the basic syntax for an array is the type name. So I guess what I'll just do is I'll type above here. So type name, and then you have these brackets. You're declaring an array and not just a regular type name variable, because if I left these out, then how would the compiler know that I wanted to declare an array? So like you need these brackets to indicate that you're declaring an array, have the variable name. So I guess I'll use the camel case, variable name. And then you can either assign it right away, or you can just have it just declared, not initialized. And you can see in this example that they set it to null because, I mean, you don't necessarily have to, because it's set to null by default if you don't explicitly do it. But it's just a good way to like, I guess, be clear on like what array is set to like from the beginning, because just to clear up that it's not initialized. So Hannah, are there any questions in the chat?
No.
Asta
Okay.
just joined.
Hey, Asta.
All right.
Hey guys.
Um,
Hey, Asta.
do you also want to show them, Stephen, how you can declare it and actually like initialize like values in the array, like with the
yeah. Does it do that here? Yeah, it does. All right. Okay, so basically, you have the type name, the brackets to indicate that it's an array, and then the variable name, to just name whatever variable you want for the array. So whenever you reference that variable name, it'll basically reference the array that you created. So to actually create an array, you use the same syntax that you would object, except instead of having the parentheses, like if you say like new int parentheses, you just have the brackets for the array. And in these brackets, you indicate the size of the array, because whenever you create an array variable, so like in this case, we create like int brackets high scores equals null. I mean, that variable that will be used to refer to an array, but it doesn't actually create the array, and like it doesn't indicate like the size of the array. Like it only indicates like what type of items are going to be put into the array. So to actually create an array, you have the variable name, and then you set it equal to new, and then the size of the array that you want to create. So in this case, they have high scores is equal to new int brackets 5 brackets end bracket. And so basically that does is that it creates 5 integers on the heap. And that's basically what your array is going to be. You can see right here. And whenever you have an array of a numeric type, like integers or doubles, I don't know if it works the same way with floats, probably does, but I'm not 100% sure. But each of the boxes in the array are initialized to 0. But if you are creating an array of like a class instead of like a primitive, then it will initialize all the values to null. If you just use the syntax for creating an array and you don't actually specify what's in the array, you just specify the size, then by default, it'll either initialize it to 0 or initialize it to null if it's a class. So does that make sense?
It makes sense.
All right. So now to actually specify what you want into the array. So one way is if you know like exactly what you want in the array, then you can just do it in one statement. So like if I say, let's just say my array name is numbers, and what you can do is you can actually use these curly brackets and I forget. I'm thinking of C. When you initialize an array, do you have to do new int and then the curly brackets? Or is it just int numbers and then curly brackets?
Is it like new integer and then you add the brackets that you already have?
No, I was asking Hannah and Asta, but
oops, sorry, my microphone was off. Yeah, you just put the values inside the curly brackets like that. Yeah.
Yeah. Yeah, sorry, I was kind of having a brain fart, but anyway, so if you wanted to initialize them in one line, then you just use the curly braces and specify each element of the array. So you don't have to specify the size because it's kind of implicit, since it'll create an array of size 5 because you have 5 elements specified. and it'll put these numbers into the array in the order that you declare them in. So it's actually, I'm going to kind of just delete everything else in this example just so that I can get an output. So, oh, whoops. So, oh, and also if you want to, if you have an array and you have things that are actually in the array and you want to access what's in the array, you basically, you use the variable name. So in this case, it was numbers, and then you use the brackets again, but then you put in the index of the access. So like, if I want to access the first element, then I would do index is equal to 0 element. Then I do index is equal to 1. Third element, index is equal to 2. And I'll explain more about that later of why it starts at 0. But for right now, I'm just going to print out the first 5 elements. So all right. This. And then it'll pretty much just print out all the elements in our array, one line after the other. And so that's just a simple way that you can declare an array in one statement if you already know what you want to put in the array. And it kind of just creates to fit whatever you declared. So they pretty much just go over this here. Hannah, should I go over like length, array length?
Yeah, you can go over that.
So an array length is basically the size of the array. So arrays, like, the thing is, have you guys learned about mutability at all?
Wait, you said mutability?
Yeah, yes.
I never heard of it.
Okay, so I guess not to confuse you, I'm not going to talk about it, but just know that arrays, once you create an array, you cannot change the size of the array. I mean, you can change the elements that are in it, but you cannot change the size of the array like once it's been initialized. And that's very important because you're going to need to know the length of the array. Like, so let's say you want to like iterate through all the elements, then you're going to want to know the length of the array to know when you want to stop iterating through the elements in the array. So for this example, they are still using the same high scores array with the elements 99, 98, 98, 88, and 68. So what this line 6 is going to do is it's basically going to print out the length of high scores. And what do you guys think that this is going to print out if it prints out the length of this array?
It's going to print out 5, right?
Okay. And is anyone saying something else in the chat?
No.
All right. So if we run this, So pretty straightforward. It's important to note that length corresponds to the length or the size and not the index. So it's like the actual number of spaces in the array, if you want to think about it like that. So, all right. And then I think the last thing I'm going to do is I'm going to talk about why indexing starts at 0 and not at 1. A complicated reason, because I recently just learned about it myself, but just to kind of simplify it, is that you have zero-based indexing in like pretty much most programming languages, or at least most object-oriented programming languages. So it's always important to remember that the index does not always correlate with the size. In fact, most of the time it doesn't, because the index will be 1 off. If I wanted to iterate through all the elements in this array, actually, this is Java, never mind. Excuse my bad indentation, but if I was to print like each number, the index, okay, so like it starts at 0, but how many times would this loop actually run?
Wait, you said how many times is the loop going to run?
Yeah.
Okay, let's see how many times it's going to run.
It's kind of hard to see because I can't really, actually, can I? I think I can.
Oh, wouldn't it run 6 times?
Why would it run 6 times? Actually, let me, I really wish I could just get this output off the screen. But you said 6 times?
Yeah.
Okay, give me your reasoning on why it would run 6 times.
Because it's starting with 0 and then it's going to go, so that adds 1 to the length.
It adds 1 to the length?
So, because the length of the array is 5, but it's starting at 0, so wouldn't it go 1 more?
Okay, well, when you're looking at this Boolean condition, it's saying that index is less than numbers.length. What is numbers.length in this case?
It's 5.
5?
Yeah.
Okay, so it's 5, but the thing is, this Boolean condition says that the index has to be less than 5. So
yeah.
What would happen if we increment this index and then index gets to 5?
Oh, okay.
It will terminate. It will break.
Exactly. So like, think about it like it starts at 0, but if we went over how like for loops work, we have the initialization, we check the Boolean condition, we go in and we increment it, and then we check the Boolean condition again, and then if it's still true, then we keep going through the loop and keep doing that. So even though it starts at 0, this loop, since it's checking if index is less than numbers.length, it would run times. Because it would because by the time it got done with the 5th iteration and then it increments index, or sorry, no, it got done with the 5th iteration and then numbers at index is equal to 5, and then it increments index again, index is 5 and is that less than numbers dot length? Well, 5 isn't less than 5, so then it would terminate. And I guess I could see why it'd be confusing because I use the index as 0, even though I used 1, 2, 3, 4, 5 in the actual numbers that I used. But it's really important to recognize that because on the AP exam or just in programming in general, they usually will put like indexing at starting at 0 instead of 1 because that's how most things work. Arrays because if you started the index at 1, then you'd be starting at 2 instead of 1. Like 2 the element instead of 1 the element. So does that make sense?
So it's like you're saying if the index was 1, we'd be starting at 2, then it would just increment and then it would just be weird. It'd be like it would take 5 times or 4 times for it to terminate if we would start the index at 1, right?
Okay, let's actually start the index at 1. What happens?
Oh, it only
is
run
this.
4 times. Wow.
Right.
That makes sense. Because 0 will equal 1 because 1 is the first index. Like 0 will be like your first index.
Yeah, exactly.
Element.
All right. So I'm gonna stop there because we have more stuff to go over. So I'll hand it off to.
Okay. I think that Asta is.
Oh wait, is she not here?
Yeah.
Nope.
Oh man.
So I guess I'll share really quickly her part. We just have like a little list for you guys of common mistakes that people make when they use arrays. And I think that this is in your ebook if you guys want to go back and look at this. But most of these Stephen has already talked about. Really just the big one that a lot of people mess up on is not starting at 0 for the first index. So that is something really important that you guys should try to remember, that when you are using an array, even though the length of an array it starts counting as 1. Like if you have 5 elements, then the length of the array is going to be 5. It's just important to remember that the index will actually start at 0. So the last index would be 4 in that case. And then, so if you do end up going out of bounds when you are looping through an array, so that would be an example of going 1 past the length. If you were thinking that the counting started at 1, then you get something called an array index out of bounds exception. And if you guys have started coding with arrays in your computer science classes, then you may have seen this exception a lot. So that's just something to watch out for. But yeah, those are the main things. And then the other thing, as Stephen talked about earlier, it's really important, since arrays are an object, you actually have to initialize it. So set it equal to new, and then the size. Because if you just had int nums, that only creates the reference that is going to point to the object. It doesn't create the actual array object. So now we are going to start going through some examples for you guys. 1 second. Let me turn off my screen sharing. Okay. So I'm going to send you guys the link to an example in CodingBat. And so I want you guys to try to solve this problem yourselves. And then after a couple of minutes, we'll go over it together. So the code is in the Google group chat if you guys want to click that link. Does everyone see it?
Yep, I see it.
Yeah, I got it.
Okay. So we'll give you guys a couple of minutes to try to solve this problem, and then I'll go over it. Oh, and if you guys finish, you can just comment done in the group chat.
Oh wait, this isn't C.
Are you doing it too, Stephen?
Yeah. I did null in all caps instead of in all lowercase, so I forgot.
Okay, do you guys still need more time?
Yep, I'm almost done.
Okay.
Yeah, just a bit more.
Okay.
Yeah, me too.
Oh, also left again.
Yep.
She left again.
Oh wait.
Oh,
Oh my god.
Oh my god.
I just finished, but I think my code is wrong.
You can actually run it to test if it works or not if you press the go button.
Yeah. It says it says there's a syntax error about like a token. Some 28.
Okay. Do you guys want me to start going over it now?
Yeah.
Yep.
Okay. I'll share my screen again. Okay. Do you guys see my screen?
I don't see it.
You don't see it? Do you see it now?
Yep, I see it.
Okay. So this is how I did it, and there's multiple ways that you could have done this problem. But so I created an integer that I call num2s. That's going to count the number of 2s that we see in the array. So then I have a for loop that's going to start at 0. It's going to go until I is less than the length of the nums array. And each time we go through the loop, I is going to be incremented by 1. So then in the for loop, we have an if statement that says if in our nums array, whatever index I is on, if that is equal to 2, then we're going to add 1 to our number of 2's arrays. So then it's going to go through the entire array since it starts at 0 and goes until the length of the array. And then after that, we're going to check to see if the number of 2's times 2 is equal to 8. And if it is, then we're going to return true, because that means that the sum of all the 2's in the array is exactly 8. Or if not, we're going to return false. So does that make sense to everyone? Or is anyone confused about anything?
Oh yeah, I realized what I was doing wrong.
Okay. Did anybody else have a different way that they solved this? Or no?
I can. Oh, second.
Oh, hello? Did someone say something? No? Okay. Well, okay, so that was our first example. And Asta, are you on? Can you do your example? Hello?
Oh, she got to go.
I'm not sure. It says that she's here, but
Her mic is on mute.
okay, one sec. Asta, can you hear me? Okay. I guess should I just go through my next example then? That's a little harder. Yeah, I don't think she's here. Okay, so did everybody understand that example pretty well? Because the next one that we're going to do is harder.
Yeah.
Okay, so everybody gets that? All right. So, like we were talking about earlier, arrays cannot change size, but there's a little trick that you can do if you want to make an array bigger or smaller that we're going to teach you guys through through some AP problems that we've seen on past tests. So I'm going to copy and paste for you guys a problem into the group chat, and we're going to talk about it, but I'm not going to have you guys code it. We're just going to think through kind of what strategy we want to take, and then after that, I'm going to show you guys how to code it. Okay. So this is actually a problem that I did in my computer science class when I was in high school and taking the AP test. So a customer at the supermarket can add as many items as they want to a shopping cart, and the shopping cart is going to be represented by an array. And so we want to write a method called add item that adds a new item to a shopping cart represented by an array. So kind of the issue, I guess, with this problem is that we want to add as many items as we want, but at the same time, when you declare an array, it has a fixed size. So we have to figure out a way that we can keep adding items to this array, even though it has a fixed size. So does anybody have any suggestions of how we can do that?
Don't you have to use an array list?
No, we can do this without using an array list. It might take you guys a second to think about.
If they say to use arrays, then use arrays.
Mhm. Anybody else have any thoughts?
Is there a way that we can use like a string, but then we can just leave just quotation marks and we can just add stuff in there by just leaving it empty?
No, because remember, arrays and strings are different. So you could have an array that holds strings in it, but they're two separate types of objects. In
Oh,
Java.
okay.
Okay. Does anybody have any other ideas? Or if not, I can go over it. It's kind of tricky to figure it out if you've never seen this before. No other thoughts? Okay. So the trick to this problem is what we want to do is create another array, so like a temporary array that's bigger than the original array, and then you copy all of the values from the original array into the temporary one, and then you copy back the whole temporary array back into the original array. So I'm going to show you guys how to do that now. Here, okay. Okay. Can you guys see my screen with Java Visualizer on it?
Yep.
Okay.
Yep.
So here I just have a class that I named grocery shopping. And so in main, we're going to create a shopping cart array. And I just made it to be a size 5. And so the first thing that we're going to do in this array is add some bananas into it. So I'm going to show you guys. Processing. Okay, so we're in this for loop over here. And so we're going to do the same thing that we did in the last example. We're going to go through every element in the array by using an integer called I that starts at 0. And we're going to keep going until I is less than the length of the shopping cart. So then in this array, we're just going to fill it with bananas. So you can see over here as it goes through. It's just filling with bananas. Okay, so now our shopping cart array is full, but we want to add this new item to it, cereal. But the problem is that our array has a fixed length that is already full of elements. So to fix this, we are going to create a method called addItem, like the problem asked us to do. And within this method, we're going to take in as parameters our shopping cart array, and then the item that we want to add, so the cereal. Okay, so the first thing that we're going to do in this method is check to see if the shopping cart is already full. And so how we are going to do this is within our shopping cart array, we're going to access the last element of this. And so remember, the last element of an array is always going to be its length minus 1, since the indexing starts at 0. And so if that element is not equal to null, that means that there is an object in it, and so that means the array is full. Does that make sense to everyone?
Yeah.
Okay, so if that is true, then we're going to go into the statement, and we're going to create another array called temp, just like standing for temporary, and it's going to be another array of strings, but it's going to have double the length of the shopping cart. So then we're going to go through, and for every element that is in shopping cart, we're going to copy it into the temporary array. Do you guys see that? Does that make sense?
Yeah.
Yeah.
Okay. So then after we get through that, I'll show you guys visually what it looks like. Okay. Sorry, I have to go through this again. Uh-oh. Wait, let's try it again. Sometimes Java Visualizer doesn't like to work. Okay. So here you can see we're creating our new array temp. And then we're going into the for loop and we're copying every single element from shopping cart into temp. Okay. So then once we copy all of the elements, you can see we still, since the length is double that of the shopping cart, we still have 5 more places to fill with more elements. So that's when we're going to go back in and we're going to take our item, so the cereal, and we're going to put that into the next element of the array, which is going to be shopping cart.length. And then after that, we're going to take our shopping cart reference and we're going to point it to the temporary array. So then shopping cart will be this temporary array object, and we're going to return that, and that will solve our problem. So does that make sense to everyone? Why that works?
Yeah. Just give me a minute.
Does anyone have any questions? It's a little bit tricky to understand at first.
Oh, it makes sense. I just wouldn't be able to do it like off the top of my head if I saw a question like this on the AP exam.
Yeah, so the important thing to remember if you ever run into a problem like this, because Asta was also going to do an example where we shrink the array instead of make it larger. And so whenever you have a question that you want to change the length of an array, the important thing to remember is that you're not allowed to do that because, like we said, an array has a fixed length. And so you kind of have to cheat the system a little and create another array that's bigger or smaller. Everything to do that. So that's just the important thing to remember. Whenever you have a question that asks you to change the length of an array, you're not allowed to do that, and so you have to create a new array.
Okay.
So does that make sense to everyone?
Yeah.
Mm-hmm.
Okay. Steven, did Asta put her example in the document? Because
Let me check.
I don't think she's has connection.
This might be the one that you just went over. Come on. Yeah, this is the one that you just went over. She has one, but like she doesn't have. It's not like a coding that problem. It's kind of just like. Oh wait. What is this?
Okay. No. I think that this is the example that she went over.
Did you find it?
Yeah, it's like at the bottom of the Google Doc. I guess we could try to go over it, but we also only have like 8 minutes left.
Do you think that'd be enough time?
I mean, do you guys have any questions so far, or do you guys feel good about this? Because if you guys feel good about it, then I guess we could try to go through her example also.
The name of that
It's like I
website,
understand.
the name of that website, was it Java Visualizer?
Yes.
Okay, cool.
And so
Thank you.
I can send you guys that example that we did later,
Okay, nice.
so you guys can have that. But yeah, does anybody have any other questions, or do you guys feel good about what we've gone over so far?
Oh yeah.
Yeah, I feel good about it.
I understand some, but I don't understand all of it.
Okay, are there any big things that you're confused about still?
It's just the shopping cart problem.
Mm-hmm.
It's just I don't fully understand it, but I can see how the first part of the code works.
Okay. Well, like I said, we can send you guys the code for that so you can go over it again. And if you still don't understand it, then you can go over it in a one-on-one session.
Okay.
But so I guess we can try to go through Asta's example then. Me and Steven haven't really seen it yet, so we're going to be all going through it for the first time together.
Yeah.
Okay. So can you guys see my screen?
Oh wait, I know what this is. It's removing like something in the middle of an array.
Oh, okay, got it. Okay, so okay, do you want to go over it then, if you know what this is?
Wait, let me just look at it a little bit.
Okay, yeah, I mean, we can like try to go through it together.
Okay. So do you want me to share my screen?
Yeah, sure.
All right. So, do you see? Can you guys see my screen?
Mm-hmm.
Yep, I can see it.
All right. Is this big enough? Can you see this code?
Yeah.
Yep.
All right. So in her array, it's basically we're trying to remove an element from the array and then make the array smaller. So in this, she has a main method and she creates an array called test, where she has all these just integer elements. And then she declares another array where she calls a toRemove method on test and removes the element 6. And so let's go to the toRemove method. And oh, another thing that we might, I don't know if we mentioned this or not, but you can also return arrays. So just like you can have like a return type of like an integer or like a string or a double or really just any like variable type. In Java, you can also return arrays. So that's really, really powerful because you can set arrays to stuff that you called like other methods on. So like in this case, we have the answer array, which is set to the what's returned by toRemove. So if we look at toRemove, we basically of the array, but it's going to be one smaller. We find the index of the element that holds a number toRemove. We use a for loop to go through each element. Just the element. Okay, and then we set a location equal to -1 because we want to find the location of the element that we want to remove. So we loop through each element in the array, and if the specified index in the for loop is equal to toRemove, and toRemove is just the int that we passed in this method, and that's the number that we want to remove from the array. Then we set the location variable equal to the index that we're at. And what if the element was in the array in the first place? If location is less than 0, then return null. So basically this is saying that if the location variable was not set to anything, which means that location would still be equal to -1, then we just want to return null, and then that means that the element wasn't even in the array. Otherwise, we know the index of the toRemove element And then she created an index of copy, set that equal to 0. Also created an index of origin, and set that equal to 0. Index of origin less than original is less than array.length, index of original plus plus. If location is equal to index of original, skip over it because we don't want this value to be in the array. This is essentially how we remove. We don't copy it. I'm actually glad that she commented this code.
Yeah. Yeah, does that statement make sense to you guys? Because that's like basically where she's actually saying that she doesn't want the element in the new array. Yes? Okay.
Okay. And all right, yeah. So she's basically just incrementing this index of original, and if we find an element in the array that we want to remove, we pretty much just skip over it and then just go to the next index, and we don't do. Actually, hold on. Yeah, and then we do this statement, but it wouldn't be like the next logical one. Basically, we do the statement, but it skips over the one that we want to remove, so we don't copy it. I'm pretty sure this wouldn't generate an index out of bounds. Would this generate? I'm trying to think because if it was at the end, would that and you went down to this statement be like too big for the array?
I don't think so.
I don't know. I guess I'd have to like run it, but all right.
Yeah, I think we ran it and it was okay.
Okay. Then return copy. Okay, so basically from this, I mean, this is one way you can do it where you have, and then you make a new array. Even though, wait, where's she? Yeah, and you make a new array that's like one less than the size of the array. And then to remove elements, you go through each element of the original array and then copy the elements that you want to be in the copy to the copy. So like in another sense, you don't copy the array, the elements that you want to remove.
I think I understand.
Does that make sense to everyone? Or is anyone confused about anything?
It's pretty good. I understand.
Okay. Yeah, these are definitely two more difficult array questions. So if you guys understand these well, then that's like a good indicator that you guys have gotten a pretty good understanding of how arrays work. Okay. So that's all that we have for today, unless you guys have any other last minute questions, or like we said, if there's something that you really don't understand, then we can go over it in a one-on-one session. But any last minute things?
No, I think I'm good.
No.
You guys are good?
No, I'm good.
Okay. All right. That's all we have for today then. Yeah, so have a good rest of your weekend, guys.
You too.
Yep.
See you next time. Bye.
See you guys.
Bye, guys.
Yep.